Welcome back to Let's Code. I'm Chris Biscardi, and today we're going to have a short video about the method I use to generate SRTs for the videos on this channel. Now, I use Deepgram for my SRT generation, combined with a Rust CLI to actually feed in wave files and actually generate the SRTs from the responses. But Deepgram has a feature called utterances that we were using for this previously, and that results in very large paragraphs almost. So you can see an example of an SRT right here for the scoped threads video. And here you can see the new format. So the core of the logic is hidden in this from implementation for this response type from the Deepgram API. SRT then is just a struct that we've defined. And we get, for each channel in the audio track, we get one of a possible number of alternative implementations or variations on what could have been said. So we take the response and we go into the results, and for each channel, we iterate over it. And then for each channel, we get the alternatives and we iterate over that. The alternatives gives us access to a list of words that we can iterate over. And we can use the itertools trait to do chunks in numbers of 5 or whatever number we want. So we have to pull in the itertools trait, which is an extension trait, which extends the capabilities of iterators in general. And that gives us this new chunks function. This chunks function lets us chop up the giant list of words that comes back from Deepgram into groups of 5. We then have to iterate over each of the chunks because we have created from the original iterator a new iterator. We enumerate over that because we need an ID for each of the chunks for the SRT. And then we map over each chunk with the index. In this case, I've chosen to take the chunk of words, so the group of 5 words, which comes with a number of fields. In this case, the start time, the end time, and then either a punctuated word or a word. So this will be either a capitalized word or not. And I put that into a tuple. So we get the start, the end, and the actual string that we're initializing with. Reduce will take the first item in the iterator and make that our accumulator. So this is a tuple. If we bring up the types, we get F64 string. Each item is also the same tuple type because we just mapped over all the values. And then we just set the end value to whatever the item is. So the last end will be the last value set. We push in a space and then either the punctuated word or the regular word, depending on which one we have here. And then we return the accumulator. Now, it's possible that this reduce could fail. So what we get here is a sum type that we have to unwrap. In our case, it will never fail because of how this response works. And then we get the start time for the group of words, the end time for the group of words, and the actual set of 5 words. We use that to format the SRT. So if you look at the actual SRT format, we have an ID and then a timestamp, an arrow, another timestamp, and then the list of 5 words. And that's what this is doing. It's doing the ID, a new line, the 2 timestamps, which are manipulated a little bit, and then the list of words at the bottom, followed by 2 new lines. And on each of the maps that we used, we collect the first one into a string, the second one into a vec of strings, and the final one into a vec of strings. So in this case, we have an SRT string for every channel, for every alternative for each channel in the audio file, and then we return it. So if we look at the actual usage here, we get to do SRT from the response, which gives us all of the SRTs. In this case, I am iterating over all of the channels and iterating all of the alternatives with enumerate to give us that index for each of the values. So we get the channel ID and the alternative ID. We use Camino in this CLI, so all of these file types are UTF-8, and I use that to format a new file name with the original file stem, the channel ID, and the alternative ID. And when we write that out, it looks like this. So in this case, the file stem was caption, and then we get channel 0, alternative 0. In this case, I only have the one option, and I only have the one channel. But you could easily have a wave file or something like that with multiple audio channels. So that's it. That's how I'm improving the captions on this channel moving forward, which should be much better. And to sort of drive the point home, this is what the old SRT looked like, which is a giant paragraph of closed captions on the video. And the new ones should be maxed out at 5 words each, which I'm super happy about. And I hope that if you didn't know about itertools, please go look at itertools. It's a wonderful package. You can, of course, find it on docs.rs or crates.io, and it basically enhances the iterator trait with a whole bunch of additional functions that are super useful. So go check it out if you don't know about it, and I'll see you in the next video.